Welcome to Education for Innovation. I'm Dave Janosz. I'm talking with two people today that are experienced people when it comes to teaching technology and engineering concepts to early elementary age students. So we're talking today primarily with a focus on students of ages 4 to about 8 years old. Certainly what I've found in my experience doing this is that you really need to start very early for a lot of reasons. First, let me introduce our guests. We have Patty O'Brien Novak, who is an engineer by trade. She's currently doing a lot of teaching and writing about engineering, especially to young children. She's recently written a book called Engineering the ABCs. So we're going to be talking with Patty today, and we're also talking with Ginger Whiting. She's a retired elementary educator, and she currently works for a consulting company called Children's Engineering Educators. So I want to thank you both for joining me today. We're just going to start with a question, and the question is, why is learning about technology and engineering important for all students of ages 4 through 8, and what does this style of teaching and learning look like for those age levels? Patty, would you like to begin?
I sure will, Dave. Well, learning about engineering for students of ages 4 through 8 is so important because in my mind, children are natural engineers. From what I have seen, they have so many of the skill sets that engineers already use when they're doing their job. And yet, many of them do not even hear the word engineer until maybe age 10 or 11. And if they have heard the word engineer before age 10 or 11, they often think of someone who drives a train. And so to teach engineering to young children aged 4 to 8 doesn't have to look much different than what some teachers are currently doing. Engineering is about teamwork and critical thinking. And, for example, in my daughter's kindergarten class this year, I saw many examples of what could be great engineering projects. And with a few small changes in the process and a few small changes in the vocabulary and the wording, those teachers could have an engineering project out of their current projects. And I do try and let the teachers know about those when I do see those. I see those as opportunities for expanded learning. At this young age, repeated exposure to a variety of topics is so beneficial to their growing minds. And I just love seeing those connections. I can tell they're making the connections in their brains, and that's really fun. And for them, the learning is hands-on, team-oriented projects. And that's what I'd like to convey to a lot of the teachers and parents out there, that teaching engineering at this young age is not about teaching differential equations. It's about modifying some of these hands-on projects just to include at least some of the vocabulary so that they're aware that engineers do more than just drive a train.
So, Ginger, why is it important, and what does it look like from your perspective?
Well, from my perspective, it's much the same, but I look at it from what needs to be taught in the classroom, too. And I'm one of those teachers that really thinks that you need to teach children and not teach standards. Teach the children the standards, but you're still teaching the children. So they need to understand about the world around them if they're going to make decisions about their future. And this includes a lot more than the natural world. And generally speaking, in curriculums today, we do talk a lot about science and natural world, but not very much about the human-made world, or what we call technology. And part of what we're dealing with now is vocabulary. And children need to understand that technology is everything that's been human-made or human-altered. And once they begin to grasp that, then the rest of it starts even making more sense. Then they learn that engineers use the math and science and the technology to solve problems. Kids need to understand how things work. And in the past, when I was growing up, we learned things, working with our parents around the house. If the TV broke, Dad took the back off the TV, pulled out the tubes. We took a trip to the 7-Eleven, tested which one was bad, bought another one, and kind of plugged it in like you do a light bulb. Today, something goes bad in a flat-screen TV, there's nothing for us to see. So kids, a lot of it's hidden behind things. A lot of how things work today are very small, and kids can't see how it works. So we need to let them see how things work. And the best way to do that is for them to get their hands on stuff. And when they're doing all of this, then they're going to learn to start learning that technology is good, technology can be bad, it can be consequences, and all of that turns them into problem solvers. They need to have hands-on real-life related problems to work so that they can learn about it. It doesn't look like just one thing. It's almost two parts in a classroom. A part you can see, a part you can't see. The part you see is designing and building, and the kids are designing and building, maybe starting from a design brief or a challenge. It's hands-on. It can be very noisy because there's a lot of collaboration going on between kids. It can be messy because at that level you're going to use a lot of found objects, so it's very inexpensive, but at the same time it can look messy and be messy. It'll be very active when it's going on, but the kids will be on task. Our experience, it doesn't matter if a child has been diagnosed with ADHD or if a child has a learning problem or a child is gifted. It works for all of those children, regardless of their learning styles. Teachers have to be very aware of what technology is. They have to start using vocabulary. They recognize when they're talking about now and then in the social studies class that they're talking about technology then and now very often. We have to encourage teachers to use the right questioning techniques and use those with lessons that are already going on, not with brand new lessons, but with lessons they're already teaching. Because there's a lot of technology education and engineering education already going on in the classroom. They just don't recognize it.
Certainly I just wanted to reiterate that we're not talking about making this a special subject or a pull-out subject, as they would, sometimes call it in elementary schools. It's really something that can be, integrated into what the teachers are already doing. And in some cases, as Ginger points out there, it's already being done. It's just that, we want to make it clear, what can and should be done and make it happen the right way so that students recognize it as engineering.
At 4 to 8, they're like little sponges.
Right.
And they're also not afraid to make mistakes yet.
Right.
So if you introduce the design process, a simplified design process to them at that age, then they start building the working knowledge of the design process. And every year, when the challenge is given to them might be just a little bit more difficult, they build on what they learned when the previous year or on previous design projects they've done. But if you start them at 4 and you start making them understand there's more than one right answer to most problems, it becomes easier and easier to keep that open mind.
My understanding always has been that, there's research that demonstrates that actually negative attitudes toward technology can form, as you get up in later years, and those negative attitudes can start as young as, say 4, 5, or 6 years old. So that's one of the other reasons that this is so important. And, actually it's a related issue to that, is that the issue of young girls and women becoming involved in technical and technological and engineering-oriented careers is an ongoing problem. And, really unless we start very young with them, the interest seems to die out at some stage of the game, and we just want to make sure that we start everyone young as possible on this, and then, once we do get them started, we don't want them to end up in an upper elementary experience or a middle school experience or a high school experience that's absent of this. So we're always talking about why this should be, a K-12 or a pre-K through 12 approach to teaching this stuff. So listen, let me thank you both again for joining me today. Patty, again, congratulations on your wonderful book and all the work that you've done in this area. And Ginger, congratulations on all the work that you've done with all the students that you've impacted in this regard over the years. Thanks to everyone, and we'll see you next time.